Review, Chapter 3. This is going to be the first half of the Chapter 3 review, 3.1 through 3.3. So let's get started. 3.1 was on lines and angles, and we are asked to find segments that are parallel to segment RU. So we're going to look at our diagram here, and we're going to find segment RU. So now, who is parallel to RU? Well, we have a segment VY, which is up above it, and then we look across at the other side. We are working on the left side plane, so we go to the right side plane, and that would include segment ST and segment WX. So we put in that one. It's parallel, parallel, and parallel. Okay, let's erase those. And the next one is segments that are skew to segment SW. Now we know that skew means non-coplanar, not parallel, and do not intersect. So we need to find segments that are not parallel and non-coplanar and do not intersect. So this segment right here and this segment right here would be non-coplanar, not parallel, and not intersecting. So let's do segment RU and segment VY. And let's look and see, are there any others? What about this segment in the back? Let's erase our other two so we can see them. This segment in the back, would that be, that's not in the same plane? It's not going to intersect, and it's not going to be parallel. So that segment and the one back behind it there, I'm erasing all of them here, that one back behind it there. So we could also include segment YX and segment TU. All right. Next says two pairs of parallel planes. Well, we have a lot to choose from here. So we could use our front plane and our back plane, and we can name those with a minimum of 3 letters. So planes, but since they have 4, I like to use 4. It doesn't matter. Minimum of 3 letters, remember, naming planes, RVWS, and since we started on R, let's start on U, Y, X, T. And we could do the left side planes. So that would be planes RVYU, RVYU. And remember, you can't lift your pencil. It doesn't matter where you start and doesn't matter which direction you go, but you have to work your way around without lifting your pencil. So the other, that's the left side plane. The right side plane would be, where did we start? We started at R, so let's start at S, SW, XT. And we'll erase that one. So we've done the front plane and the back plane and the right and left plane. So now let's do the top and bottom. And those would be planes. Let's see the top. Let's go VYXW. And the bottom plane, where did we start? We started at V, so let's start at R. We went around clockwise. RUTS, plane RUTS. So we were only supposed to name 2, but we named all 3 sets of parallel planes. All right, and lastly here, segments that are parallel to plane RUYV. So let's go over and find RUYV. All right, so we want segments that are parallel to that plane. So our top and bottom segments over here on our right-hand side, that's our left plane, so our right plane would be good. So segment WX and segment ST. Make sure you're using proper notation. If you're asked for a line, use the notation for line. If you're asked for a segment, use notation for segment, plane, point, etc. All right, and we've got those. Are there any others that are parallel? Well, what about these? Up and down are going to be parallel. So segment WS and segment TX. Now, if we wanted to get really fancy, remember a plane is just an infinite number of points. So we could draw that segment and draw that segment. We could draw any lines that we want to, but we don't need to get that fancy. Not just yet. All right, so that wasn't too bad. And we need to, the next part says identify all pairs of each type of angle in the diagram. So let's look at our angles. The first one is corresponding angles. Remember that corresponding means position. They're in the same position. Let's write that in there. Corresponding is same position, same place. So let's go find our corresponding angles. We're going to have 7 and 3. So corresponding angles are angle 7 and angle 3. And who else is corresponding? We've got 6 and 2, so angle 6 and angle 2. And who else is going to be corresponding? Well, it's the ones that aren't marked now, right? So we're going below and to the left of our lines. So angle 5 and angle 1. And on the other side, top and to the right, is going to be angle 8 and angle 4. Okay, you should be able to recognize these angle pairs just automatically. So if you're having trouble seeing them, make sure that you practice these. Next are alternate interior, so that means opposite sides of the transversal and inside of our two lines. So who's alternate interior? Well, let's start with angle 5 and angle 4, and then that leaves angle 3 and angle 6. Okay, those are very useful to us, should be some of our favorites. You should be able to recognize those very quickly. All right, same side interior. So these are on the same side and inside. We just did opposite sides and inside. Now we want the same side. So who's on the same side? Angle 3 and angle 5. And on the other side is angle 6 and angle 4. Again, make sure you're using proper notation on these. All right, next is alternate exterior angles. So that means they're on the opposite side of the transversal and outside. So let's find our outside angles, 7, and who is opposite of that? 2. So we have angle 2 and angle 7, and who else is out there? Angle 1 and angle 8. So those are our alternate exterior angles. And then we are asked, oh, hey, we are familiar with these, vertical angles. We know our vertical angles. Some old friends of ours. They are where two lines intersect. Anytime we have two lines intersecting. So we know that vertical angles are there, angle 1 and angle 4, and also the other set right there. So angle 2 and angle 3. And we also have them up on the top. So angle 5 and angle 8 and angle 6 and angle 7. Vertical angles are something you should be actively looking for because we are going to find them everywhere. And last here, we are asked to name the linear pairs. Linear pairs are everywhere. So we are going to look here and we are going to see that angle 1 and angle 3 are linear pair. But if we also look, angle 1 is a linear pair with angle 2. So angle 1 and angle 2. All right. And then we see that angle 2 is also going to be linear with angle 4. So angle 2 and angle 4. And I'm sure you can see already that we're going to have up on the top angle 3 and angle 4. So those are all the linear pairs. We just went around that set of intersecting lines. And now we have the ones up on the top as well. So let's just write those in, angle 5 and angle 6. Anytime our two angles, adjacent angles that form a straight angle, form a line, we have linear pairs. So angle 6 and angle 8 and angle 8 and angle 7 and angle 7 and angle 5. So we had lots of those. You should be able to recognize all of these special angle pairs. These are our 6. All right, let's move on to 3.2. This is where we started to put all of this terminology to use. It says, find the measure of angle 1 and the measure of angle 2 and state the theorems or postulates that justify your answers. Well, that's something fun that we like to do. So let's look at our diagram. And what do you see? Something that we are actively looking for is we have parallel lines. And our parallel lines are cut by a transversal. Okay? And that means our special angle pairs have special properties. So the first thing I'm seeing here is I'm given angle 58, and what do we have here? We have alternate interior angle theorem, right? So the measure of angle 1 is going to equal 58 degrees. Now, what else do we have going on? Well, the angle that we're given and angle 2 are same side interior angle theorem. And we know that if we have parallel lines cut by a transversal, same side interior angles are supplementary. So the measure of angle 2 plus 58 degrees equals 180 degrees. We just subtract 58 from both sides. And the measure of angle 2 is 30. That's an 8. 122 degrees. So we could come in here, we could label this one 122 degrees, and we could label this one 58 degrees. Okay, easy enough? All right, let's look at our next set here. I see lots of parallel lines. Do you see all those parallel lines? Those lines are parallel. These lines are parallel. And that means we have tons of transversals. So let's find the transversal that means something to us. Okay, we want our angles to sit on that transversal. So there is angle 1 and our given angle. And how do these two angles relate? What position are they in? Those are corresponding angles, and the corresponding angle postulate tells us that corresponding angles are congruent. So the measure of angle 1 equals 103 degrees. All right, so we have used that transversal, and we are going to label angle 1 103 degrees. And now we need to relate angle 2. So we are going to use a new transversal. That's not the color we want. Transversals are green. So we have a new transversal that goes with those parallel lines, the horizontal parallel lines, and now we can relate angle 1 and angle 2. And how do those angles relate? Those are alternate exterior angles, and the alternate exterior angle theorem says that alternate exterior angles, when they are on parallel line cut by a transversal, they are congruent, so we can say the measure of angle 2 is also 103 degrees. So we can go in and label that as well. Find your transversal Once you have parallel lines, you know our special angle pairs have special properties. Find your transversal and use it to your advantage. All right, the next set says find the value of each variable, justify your reasoning. All right, well, I see parallel lines and I have a transversal. Good stuff. So now, what types of angles do we have? Well, here and here. And remember, if you have difficulty, go ahead and turn your paper so that you can compare it to the angles in your notes, the diagrams in your notes. But we can see that these are alternate interior angles, and the alternate interior angle theorem says that these two are congruent, which means we have an equation, 3x minus 44 equals x minus 24. Definition of congruence is equal. Measures of angles are equal. So let's just work through the algebra here. I subtract x from both sides. I add 44 to both sides. And I get 2x equals, what is that, 20? So 2, so x equals 10. And if I wanted to, I could go in and I could substitute a 10 in there. Ooh, that would not give us a good, never mind, we aren't going to do that. Because I'll just get upset with the book. We're going to have negative angle measures. So we won't do that. We'll just solve the problem. We found x equals 10. Just said find the value of the variable. Okay, yay, we did that. All right, let's go to the next one. Oh my, we have lots and lots and lots of lines. I see that these two lines are parallel, but that is all that is parallel. So let's find our transversal. I see a transversal right here. And what type of angles do we have here? We have alternate exterior angles, and the alternate exterior angle theorem says that these are congruent. So we have 5x equals 3x plus 34. Subtract 3x from both sides, just do our algebra. 2x equals 34. Divide both sides by 2, x equals 17. Yay! Now, I see another transversal over here. Yes, I let my transversal be light blue. It's close to green. Same family. What types of angles do we have here? We have same side interior angle. And what does the same side interior angle theorem say? It says that if we have parallel lines cut by a... Oh, I'm sorry. I don't know what I'm doing. Trying to erase, that's what I'm doing. Those are not same side interior angles. Those are corresponding angles. All right, corresponding angle postulate. And I know you caught that. Say, what is she doing? All right, so we know that the corresponding angle postulate says if we have two parallel lines cut by a transversal, then corresponding angles are congruent, so we can write an equation, probably because I didn't use green for my transversal. Blame it on that. All right, so I like to do my y's first. What happens if I subtract 2y from each side? I get y minus 35 equals, what's 2y minus y? It's just 0. 0 is a number. Don't be afraid of 0 in an equation, because now I'm going to add 35 to both sides. 0 works. 0 is just a number. We like all numbers. So now y equals 35. And our last one here. Oh. Well, those are supposed to have parallel marks on them. Those lines are parallel, by the way. A is parallel to B. We're going to write that in. A is parallel to B. So we went in and marked it ourselves. We'll pretend that happened. Okay, let's take a look at what angles we have here. we have this angle here. Let's find our transversal. Let's put it in green this time. Make things work a little better. And this angle over here. Those are not any of our special angles, are they? But look what we can do. We can make this angle measure 104 degrees because these are vertical angles. So our vertical angle theorem says that these two angles are congruent. And now, what types of angles do I have? These are the same side interior angle theorem that says they are supplementary. So I can say 2x plus 2 plus 104 equals 180. So 2x plus 106, 180, subtract 106 from both sides. 2x equals 74, divide by 2, and x equals 35 plus 2, 37. All right, so that allows us to use our special angle pairs to find angle measures. All right, what's next? Oh, a proof. Woohoo! Everybody loves a proof. All right, so let's use our define explore. Let's use our ideal process here. Let's see what we know. We know that line L is parallel to line M, so let's go over here and find L and M. There they are. They are parallel. And line A is parallel to line B, so those are marked. All right, that means we have lots of stuff going on here, lots of transversals happening. So we might actually want to go in. Let's look at where our lines are here, where our angles are, what we're trying to do. We are trying to prove that angle 1 is congruent to angle 5. Now, this is kind of a very kind proof here. You can see that it's going to lead us from angle 1 to angle 2 to angle 3 to angle 4 to get to angle 5. But there's a lot of lines here. There's a lot going on. So we are going to do our define and explore, and we are going to redraw. And so I have, this is line A and B, and we don't have to be fancy over here. And this is line L, okay? And we have angles 1 and 2 on that. Now, how are angle 1 and 2 related to each other? Well, we know that 1 is going to be congruent to 2 because of vertical angles, right? Our vertical angle theorem. Notice here in my brainstorming area, I'm not really paying a lot of attention to proper notation and, fully naming my theorems and postulates. I'm just collecting the information that I have. All right, so let's look at our next section here. How am I going to relate angle 2 and angle 3? Well, let's draw. We've got this here and this here, and our transversal is going to go across this way. And this is line L and line M, and our transversal is line A, and we have angle 2 and angle 3. So what can we do with those? I am going to write my define explore under here so it doesn't get all lost in my redrawing. So those are vertical angles. All right, so what do I know about these? Well, these are same side interior angles, right? Because these are parallel. These are parallel. We can mark that. That might help us. So we've got same side interior angles. What does that do for me? Well, let me find another color here. I know that 2 and 3 are supplementary because of same side interior angles. All right, well, let's do our next drawing here. How do we get 3 to 4? We've got to do 3, 4, and 5 here. So I've got 2 more lines there, and those are A and B. And cut by a transversal here. This is line M. And on this one, I have angles 3 and 4 and 5. They all sit on the same transversal, and these lines are still parallel. So what do you see here? I see that 3 and 4 are going to be supplementary because of same side interior. You see them here, same side interior. And I also see that 4 and 5 are going to be congruent because of vertical angles. So if we go back here and look at our original drawing, do you see how we are going to go from 1 to 2, 2 to 3, 3 to 4, and then 4 to 5? Vertical angles, same side interior, vertical. So let's figure out how we are going to put all of this together. And as I'm looking at this, I see some matchup there. Do you see those matching? Now you might think transitive property for that, but think back to chapter 2. Go look in your big packet on chapter 2, and do we have something about supplementary angles? We have a little something called the congruent supplements theorem. And it says if two angles are supplementary to the same angle, then they are congruent. So this is going to give us 2 and 4. Now, does that help us? If we have angle 2 is congruent to angle 4, does that help us get from 1 to 5? Well, hopefully you see it already. Do you see that we've got a 2 here and a 4 here? If we can get from 1 to 4, we can get from 4 to 5, or 1 to 5. We'll use 4 to get to 5. So let's see how we would put all of this together. So our first step is given, all right? And then we said angle 1 is congruent to angle 2. What let us say that? That's the vertical angles theorem. Now notice here when we're doing it in the proof, okay, that we are using proper notation and we, write out proper names, all right? And then we say angle 2 and angle 3 are supplementary. What let us say that? That was same side. That's not the color I want. That was the same side interior angle theorem. And 3 and 4 are supplementary. How did we say that? It's the same theorem, same side interior angle theorem. Now, how did we get from angle 2 to angle 4? Well, remember, we've got these two here that we have two angles, angle 2 and angle 4, that are supplementary to the same angle, which is angle 3, and we know that two angles that are supplementary to the same angle are congruent to each other. That is our congruent supplements theorem. Go in your big packet and look that up. All right, now, how are we going to use that to get from angle 1 is congruent to angle 4? Well, remember that up here we had an angle 1 is congruent to angle 2, right? That was up above. And so this, I'm just going to connect my angle 2's there, cut out the middleman. So that is the transitive property of congruence. right? All right, so now how do I get from 4 to 5? How do I get angle 4 is congruent to angle 5? Well, we look back up here. How did we relate 4 and 5? That's up in our notes, up in our brainstorming. That's the vertical angles theorem. Let us do that. And now, how are we going to get from 1 to 5? Well, we have that common angle again, which should just scream transitive property to you, and it's of congruence. So do you see how we went through our define, explore, and we figured out how to follow a path to there, and then we just followed that path in our proof. This one's a little bit longer than the ones we're going to be doing right now, but we are going to work up to stuff like this. So work carefully, think about it, make sure you do the define, explore section. Notice how I redrew each one so I could see everything, and then I wrote out everything that I know and kind of worked out the proof before I ever started writing it. And that will help you a lot. All right, so then we moved on to 3.3. And 3.3, remember, was just the converse of 3.2. So instead of having parallel lines and then the result being our special angle pairs are special, now we have, if your special angle pairs are special, then you can prove that your lines are parallel. So we are asked to determine which lines, if any, must be parallel, and then of course justify with a theorem or postulate. So let's start with our first angles. So notice none of our lines are parallel. We are trying to prove lines parallel. So let's look at angle 9 and angle 14. What types of angles are those? Those are just vertical angles. Can we prove that any lines are parallel using vertical angles? No. So this is none. This is nothing. These are just vertical angles. We know they're congruent, but they don't help us prove lines parallel. All right, let's look at the next one. Angle 1 and angle 9. So, oh, we should use different color. Green's our transversal color. So angle 1 and angle 9. Now, can we put a transversal in on those? Remember I told you, locating your transversal will make your parallel lines stand out. It's the ones that the transversal crosses, and your angles must sit on the transversal. So who can we say is parallel? What types of angles do we have here? We have corresponding angles. So we can say that line R is parallel to line S because of the converse of the corresponding angles postulate, which says if your corresponding angles are congruent, then your lines are parallel. All right, that's not an eraser. There we go. So we erase. Let's look at our next set. It says angle 2 is supplementary to angle 3. So let's find angle 2 and angle 3. And it says they're supplementary. Do they sit on a transversal together? Yes, they do. And what types of angles do we have? We have same side interior angles. And so what lines, if same side interior angles are supplementary, what can we say? We can say line C is parallel to line D by the converse of the same side interior angle theorem. All right, remember, if lines are parallel, it's always going to be a converse. Next one, angle 7 and angle 10. So there's angle 7 and angle 10. Do those two angles sit on a transversal? They do not. None. Those angles aren't related in any way. They're not on the same transversal. So those aren't going to do anything for us. That's unfortunate. Those were nice angles. All right, let's look at the next set. Ooh, angle 6, right there, is 60 degrees. And angle 13, right there, is 120 degrees. Now, do those angles sit on a transversal? Yes, we can put them both on a transversal, so let's draw that in. Now, can we use that to make any lines parallel? Well, those are not part of our 6 special angle pairs, but what if we use vertical angles? That's not the color I want. To make angle 10 120 degrees. And then what types of angle pairs do we have? We would have same side interior, and are they supplementary? Yes, 60 plus 120 equals 180. So we could say that line R is parallel to line S by the vertical angle theorem, and the converse, trying to write proper letters here, the converse of the same side interior angle theorem. So that's not directly, but it didn't say anything about directly. Vertical angles are useful. We also, on this one, we also could have done angle 14 with 60 degrees by linear pair. And then we could have used the converse of the corresponding angles postulate, because then this angle and this angle would be corresponding. So multiple ways, as always, multiple ways to do everything here. All right, we are almost done. Yay. Okay. Angle 4 and angle 13. There's angle 4 and angle 13. Nothing we can do with that. These are not on the same transversal. So nothing with those. Okay. Let's try another one. Angle 10 and angle 15. Oh, we didn't erase those. Angle 10 and angle 15. They definitely sit on a transversal. And what type of angles do we have? I see alternate interior angles. So which lines will be parallel? C will be parallel to D by the converse of the alternate interior angle theorem. Because if our alternate interior angles are congruent, then our lines are parallel. And the last one, let me erase that. And the last one is angle 1 and angle 8. Do they sit on a transversal? Yes, they do. That's not a very good transversal. That's okay. What types of angles do we have? Alternate exterior. So we can say line C is parallel to line D by the Hopefully you caught that. We're saying lines are parallel, so it is the converse of the alternate exterior angle theorem. Let's us say that. So I believe that's all for 3.3. Yes, it is. Okay, so that is our first 3 sections. We learned some terminology about parallel and skew, and then everything else was on our special angle pairs. Remember that we have supplementary angles, and who are they? That's our linear pair postulate and our same side interior angle theorem. And we have congruent angles, and who are they? Those are our corresponding angle postulate, our alternate interior angle theorem, our same side interior angle theorem, and our alternate exterior angle theorem. So, know your, no, you're letting me make a mistake here. Don't let me do that. Who are our congruent angles? Vertical angle theorem, corresponding angle postulate, alternate interior angle theorem, and alternate exterior angle theorem. Letting me put same side interior over there. So these are our 6 special angle pairs. If you have parallel lines, they are very special. Our originals, linear pair and vertical angles, they only require that we have 2 lines that intersect. They are everywhere and are always special. The rest of these require parallel lines, but then they are very special as well. So I believe that you are going to do very well on the test, and look over your proofs, think through them carefully, use the ideal method, do that define, explore, and I think you will do fabulous.